Before we get right into polar form, there are a couple things you should know. First off, recall that if you're given a complex number and you're asked to graph it, you find the x component and the y component, treat them as coordinates, and put your vector down. So if your complex number is, say, z equals to a plus ib, and you're asked to graph it, we'll go a units on the horizontal axis, b units up, and draw your vector straight through. That being the horizontal component, and that being vertical. And this angle right here is the angle between the two components. Our magnitude right here is denoted as r. Of course, it is also our modulus. Another thing to recall from basic trig is that if you're given a right angle triangle, then cosine of theta is always equal to the horizontal length divided by the magnitude. If you apply that to this complex number, it'll be a over r equals cosine theta. Same thing with sine. Sine is equal to the vertical length divided by the hypotenuse, which would be in this case b over r. This right here is the basis of polar form. Polar form is basically an alternative to express complex numbers in terms of their angle and modulus. So, if you have a complex number in standard form, such as this one, z equals to a plus ib, its polar form will be the modulus of z, which we discussed in my last video, multiplied by cosine of theta, theta being the angle between a and b, plus I, the imaginary number, times sine of the same theta. Simple enough. Quickly into an example now. Express z equals to -1 plus root radical 3i in polar form. So whenever you approach a problem where you're asked to convert into polar form, you basically have two components. First off, you need to find the modulus and then the angle and plug those into your basic formula. For our modulus, we'll do just as we did in my previous video. Take the x component, square it, take the y component, square it, put all those under a square root, and you have your magnitude, aka your modulus. So, I'll do that to the side. -1 squared plus radical 3 squared is equal to 4, 5. The square goes away, so it's 4. Put that in a square root, we get 2 as our r or z modulus. Hope you're following. Now, the only challenging part I would think sometimes is getting the angle out of this. Let's graph our complex number down to the side over here. We have -1 on the x component. So there's -1, and we go radical 3 up. Radical 3, right there. The angle we're trying to find, of course, is right here. So we know that cos of theta is equal to x over r in any Pythagorean theorem triangle, which in this case is equal to -1 over r, which we found to be 2 over 2. This looks familiar. This seems like it's straight out of any of the significant triangles which we know about, pi over 6, pi over 3, and pi over 4. So, the related acute angle over here would be pi over 6. Pardon me, it's pi over 3. Yeah, I need to review them too. So, of course we're going to get two angles out of this using the cast rule. Cosine is negative in the second and third quadrant. So the two angles we get are 2 pi over 3. We take pi over 3 for this. Subtract it from pi and get 2 pi over 3. Or for the third quadrant, we'd add it to pi and get 4 pi over 3. Now these are all potential angles, but of course we need to find an angle that agrees with cosine and sine. So now let's do sine. We know sine of theta is y over r, which in this case is radical 3 divided by 2. again, this looks familiar. The related acute angle is pi over 3. Since it's positive, we know the answer is going to be either in quadrant 1 or quadrant 2. So we have either pi over 3 as theta, or pi minus pi over 3 to find the corresponding angle in the second quadrant, which would be 2 pi over 3. Now if you compare the four angles you found, the one that you found through cosine and sine would be 2 pi over 3. And so that exactly is the angle we're going to use. Back to our question. Theta is equal to 2 pi over 3. We have our modulus, we have our angle, and we know the formula. So we plug it right in. Since r is, let's just write it down. So the modulus times cosine of theta plus I times sine of theta is equal to the polar form, which in this case, the modulus we found as 2 cosine of 2 pi over 3 plus I times sine of the same angle. Common mistake right here. People often tend to find different angles for the two sine and cos. And this right here will be your polar form of the complex number z equals -1 plus root 3i. Pretty simple if you ask me, very systematic, not too many parts to it. Now, going a little deeper into polar form, what you need to know is that you can be asked to find the polar form of two multiplied complex numbers or two divided complex numbers. In such cases, with multiplication, you'd have to multiply the moduluses. I'm not sure if that's the plural of modulus. And you'd have to add your angles. With division, you first off divide the modulus, and then you subtract, as you'd instinctively think with division, the angles. In other words, if you're asked to find the multiplication and division, you'd have to carry out this entire procedure with two complex numbers and then put them back into this formula right here. An example on the next page. So, up here, express z equals z1 multiplied by z2 in polar form, given z1 equals to 1 plus I and z2 is equal to 1 minus radical 3i. So let's do z1 to this side and z2 to this side, treat them as two separate questions. And z1. First off, with z1, our modulus would be the square of 1 plus the square of 1 whole square root. 1 squared plus 1 squared, which is equal to 1 square root, which is still 1. The modulus of z2 would be square of 1 plus the square of negative radical 3 whole square root, which would be 1 squared plus negative radical 3 squared, which is equal to 4, and then the radical of that should equal to 2. We have our modulus. On to our angles. So over here, quickly, a small graph wouldn't hurt. We have positive 1 and positive 1, so we're going 1 to the right and 1 up. There we have our vector coming down, our angle. We know that cosine of theta, oh wait, hang on a second. I beg your pardon, this is 2. What am I doing here? Radical 2, yep. 1 plus 1 would be 2. You put a 2 down. I knew I saw something. So the rest of it is fine. Cosine of theta would equal to x over r, which is 1 over our corrected r, radical 2, which is 2 over radical 2 over 2, that is. Again, this looks familiar. It's right out of a simple triangle, and our angle, without much debate, would be pi over 4, quite simply. We do the same with sine, and since we have a very simple angle this time around, we get the same angle for sine, which is pi over 4. On to the angle for Z2 now. Oops, you weren't able to see that. So for Z2, of course, this is slightly more complicated with the angle. So we graph first. We're going 1 unit to the right and negative radical 3 down. 1 to the right, negative radical 3 down. Just like that. There's theta. So we have cosine of theta equals x over r, which in this case is 1 over positive 2, 1 over 2. And since cosine is positive, we have our cast rule. Cosine is positive in the fourth and first quadrant, and the related acute angle in this case is pi over 3. So our angles are pi over 3 and 2 pi minus pi over 3, which is 5 pi over 3. There's our potential angles through cosine. On to sine of theta. It's equal to y over r, which is negative radical 3 over 2. Sine is negative in the fourth and the third quadrant, so we know our angles are going to be down here. The related acute angle, of course, we know would be pi over 3 again. So to find the pi over 3 in the third quadrant, we do pi plus pi over 3, which is 4 pi over 3. To find it in the fourth quadrant, it would be 2 pi minus the acute angle, which is pi over 3, which gives us 5 pi over 3, yay, because we've already seen that through cosine, so we know this right here is our theta. Now we have all our information, and we're simply going to plug it back into the formula we recognize. So we'll put down the formula here. Z1 dot Z2 is equal to R, I'll call it R1 times R2 multiplied by cosine of theta 1 plus theta 2 plus I sine theta 1 plus theta 2. That in bracket. Now I'm just plugging in. R1 was radical 2, R2 is positive 2. So radical 2 times positive 2 multiplied by cosine of theta 1 plus theta 2, so theta 1 pi over 4 plus 5 pi over 3 plus 5 pi over 3 plus I times sine of the same two thetas, pi over 4 plus 5 pi over 3. There we have it. And if we're to add these now, so 2 radical 2 multiplied by cosine of, I should have had this done really. You know what, I'm going to cheat and use my calculator. Of course you probably won't be allowed to do in your class. Pi over 4 plus 5 pi over 3, 23 pi over 12. Plus I sine of 23 pi over 12. And that is the correct answer. Yep, there you have it then with polar form. Thanks for watching.